Is the screen visible?
Yes, sir.
So today we'll see the next topic, the linear measurements, the first topic of your actual syllabus. Okay. So what is a linear measurement? What do you mean by linear? And what are linear measurements? What is linear? Normal English meaning of linear. లీనియర్ అంటే ఏంటమ్మా? లీనియర్ ఈక్వేషన్ అని చెప్పి వినుంటారు కదా, చదివారా మ్యాథ్స్లో?
Yes, sir.
వాట్ ఈస్ దట్?
Straight line.
సో వాట్ ఆర్ లీనియర్ మెజర్మెంట్స్ నౌ? What are linear measurements?
Scales.
Distance between 2 points, sir. Straight line.
Length, breadth. అవునా?
Yes, sir.
Just give me 1 minute. So using linear measurements are nothing but measuring the distance between two given objects, okay, either in the form of length or in the form of breadth, etc. kind of thing. So we have different types of instruments that are used in surveying: chain surveying, compass surveying, plane table surveying, okay, theodolite surveying, leveling, total station. Like this, we have several instruments. The first basic surveying is nothing but chain surveying, which is used to measure the linear measurements in the field. What is the distance between two given points? What is the length of the given line, etc. kind of thing can be done with the help of a chain surveying. So for measuring the linear measurements in the field, we need few instruments, which are ranging rods or ranging poles, chains, tapes, and arrows or pegs. These are the basic requirements, basic instruments that are required for taking the linear measurements in the field. So let us see one by one. What is a ranging rod? Okay. So ranging rods are used for the purpose of ranging, that is marking straight lines in the field. This is used if there are 2 points, if you want to establish 2 station points or 5 station points in the field, so we will be making the use of ranging rods. Okay. So it is of galvanized iron pipes made of 25 diameter, okay, and it will be circular in section, and the length varies from 2 meters to 3 meters. The rod is divided into equal parts of 20 centimeters. Here you can see the red band and white band, right? Each band, the length of the red band is 20 centimeters, the length of the white band is 20 centimeters. The main purpose of ranging rod is to establish station points as well as to establish intermediate station points between two given points. But in case when you doesn't have a chain or a tape also, you can use this ranging rod bands for rough estimation or for rough measurement. Okay. So the height is, ranging poles are a larger one whose length ranges from 4 to 8 meters in length and 6 to 10 centimeter diameter. If the distance where you are doing the surveying is far enough, if you want to have visibility, then you need to go for ranging poles, because if the height is more, you can see from the far away places. Okay. Only difference between ranging rods and ranging poles is only the length. The height or the length of the ranging rods is 2 to 3 meters. Ranging poles is 4 to 8 meters. Remaining purpose is the same. Okay. This is the first basic instrument that we are going to use in the surveying field. Then we have chains. Okay. We have different types of chains: a metric chain, steel chain, engineer's chain, gunter's chain, and revenue chain. So the main purpose of this chain is to measure the distance between two given points. You can see in the figure there are two brass handles we'll be having, and you'll be having the links. Okay, the steel, are you able to see some steel links surrounded by two rings again, two steel rings? Okay, see here. This is one end of the chain which is having a brass handle, and the other end also will be a brass handle, and the length of the chain will be engraved on this or will be printed on this. The length of the chain, if it is 20-meter chain or if it is 30-meter chain, it will be given, it will be mentioned on the handle. So by seeing that value, you can say that the length of this chain is 30 meters, the length of chain is 20 meters or 5 meters, 10 meters like that. And here you can see this one, which is, it is called as a link. Okay, you are having two rings, two bendings at the ends of the link, and each link is 20 centimeters or 0.2 meters in length. Okay, so the least count of a metric chain is 20 centimeters. Each link here, the measurement from here to here, from center of this bend to center of this bend is 20 centimeters or 0.2 meters. Okay, so if the length of the chain is 20 meters from handle to handle, how many links will be there? If each link is 20 centimeters, if the length of the chain is 20 meters, how many links will be there? Please respond. Are you getting me? If the length of the chain is 20 meters from handle to handle, and if each link is 20 centimeters, how many links will be there? Simple calculation. 200.
100, sir.
100, sir.
100. So a 20-meter chain consists of 100 links, where each link length is 0.2 meters or 20 centimeters. If it is length of the chain is 30 meters, and if the link is 20 centimeters, how many links will be there?
150.
150, sir.
150. So, okay, these are Viva questions you need to remember by heart. Okay, a 20-meter metric chain consists of 100 links of 0.2 meters each or 20 centimeter each. A 30-meter metric chain consists of 150 links. Each link is 0.2 meters or 20 centimeters. Okay. So what is the least count now? What is the least count of a metric chain?
20 centimeters.
20 centimeters. Okay. So we'll be having 100 links here and 150 links, and you can see some figures, right? Are you able to see some brass rings of different shapes on the figure? Yes or no?
Yes, sir.
Brass shapes కనిపిస్తున్నాయి కదా ఇక్కడ. This one, this and this. So these are called
Yes,
as
sir.
tallies. Okay, these are called as tallies. The purpose of providing these tallies is to aid in measurement. Okay, this tally is for 5 meters. It will be placed at a 5 meter distance from the starting of the handle. This will be placed at 10 meters distance. This will be placed at 15 meters distance from the starting of the handle. So what happens is, when you lay this chain on the ground, okay, in order to avoid this counting of the links, if suppose I have laid this chain on the ground and I want to measure a distance of 13 meters. Okay, so how many links I need to count? If I want to get 13 meters, each link is 20 centimeters or 0.2 meters. I want to measure 13 meters. How many links I need to count? చెప్పండి. I want to measure 13 meters using a chain. Okay, each link is 20 centimeters. How many links I need to count in order to reach the 13-meter mark? One meter మార్క్ చేయాలంటే ఎన్ని లింక్స్ కౌంట్ చేయాలి నేను?
5, sir.
5, sir.
సో 13 meters అంటే
60.
65. I need to count 65 links, right? Then I can say that this is the 13-meter mark. Instead of that, if you are able to identify this tally of 10 meters, this one, second one, okay, or if you are able to identify this tally of 15 meters, how many links I need to count from that 10 meters? I need to count only 15 links, right?
Yes, sir.
This mark, this brass ring on the ground will show that it is up to this mark, it is 10 meters. So from there I can count 15 links. If I count, I can say that it is 13-meter mark. Or if I am able to find this 15-meter mark, then I can say that if I count 10 links, I can say that this is 13-meter mark on the ground. Instead of counting multiple links, with the help of these tallies, you can reduce the time taken for measurements. Okay, that is the purpose of the tallies: 5 meters, 10 meters, and 15 meters. And at every 1 meter also, we will be providing a brass ring. Okay, every 1 meter also we will be providing brass ring. So we can avoid counting each individual link all the times just by identifying these things. we can easily identify what is the distance from the starting point. Okay, that is the purpose of this chain. Okay, you can see here the figure. Okay, so at every 1 meter you will be having a brass ring. At every 5 meter, 10 meter, 15 meter you will be having a tally. The length of the chain is from the end of the handle to the end of the handle. Okay, so we have various types of chains. The basic one which we generally use is the metric chain, which is available in the form of 5 meter, 10 meter, 20 meter, and 30 meter chains. And the another type of chain is engineer's chain, which is 100 feet long and it consists of 100 links. Each link is 1 feet. In metric chain, each link is 0.2 meters. In engineer's chain, each link is 1 feet. That is the least count of engineer's chain is 1 feet. Gunter's chain is 66 feet long, 100 links. Each link is 0.6 feet. Revenue chain, 33 feet link, 33 feet long, 16 links. Each link is 2.06 feet. Steel band, 20 or 30 meters. The width is 12 to 16 mm and the thickness is 0.3 to 0.6 mm. These are all will be part of your Viva questions. Okay. What is the least count of metric chain? 0.2 centimeter, 0.2 meters or 0.20 centimeters. What is the least count of engineer's chain? 1 feet. What is the least count of Gunter's chain? 0.6 feet. What is the least count of revenue chain? 2.06 feet. What is the least count of steel band? Okay. All this will be part of your questions, Viva questions as well as in the laboratory. Okay. So what are the advantages and disadvantages of chains? Okay. No doubt, it can be read easily and quickly. Can you need any engineering knowledge to count how many links are there from one point to other point using this?
No, sir.
No, sir.
So right, even an illiterate also, if you ask him to count any links ఉన్నాయి చూసి చెప్పమ్మా అంటే చెప్తాడు కదా. Even a second standard children also tell. Okay, so it is very easy to use this instrument and to read this instrument. Okay? It is very easy to read as well as use also. Okay, and as the material which is used for preparing this is steel or iron, right? So it can have multiple, it can withstand wear and tear. If you drag it on the ground also, it is not going to get deformed that easily unless and until you use very high force. Okay, a normal human pull will not be able to damage the chain that easily. It can withstand wear and tear, and it can also be easily repaired or rectified in the field. What will be the repairing chances in this? What type of problems you can expect in a chain? By seeing this chain, please tell me what kind of problems you can expect. ఏమవుతుంది మా అంటే దాన్ని మనం గ్రౌండ్ మీద వేసి లాగుతున్నప్పుడు బెండింగ్ ఒకటి. ఓకే, sometimes these rings also may get worn out, right? You can see these rings are having some opening here, right? So the rings may open when you're dragging it on the ground. If there is a small rock which is obstructing that, when you pull it fastly or hardly, sometimes the rings may open up. So what is the solution for that? These two are the problems. Sometimes it may bend, sometimes these rings may worn out. What is the solution for that? You can make the link straight by beating with a hammer.
Yes, sir.
మన ఇంట్లో మొలలు వాడుతున్నప్పుడు మొల కొడుతున్నప్పుడు మొల కొద్దిగా వంగిపోతే ఏం చేస్తాం, మళ్ళీ కొడతాం కదా సుత్తి తీసుకొని. The same we can apply here, right? If a link is bended, we can make it straight again by simply beating it with a hammer. Okay. Similarly, if a ring is worn out, ring open అయిపోయి ఊడిపోయింది అనుకోండి, you can fix it, right? Yes or no?
Yes, sir.
So for this, any engineering knowledge is required?
No, sir.
Only common sense is required. Okay. So anyone can repair the chain and ensure that again it is back into its actual shape. Okay. And suppose if at all 4 to 5 links are gone, still we can use, because we know that each link is 20 centimeters. We can count how many links are there, multiply by 20 will give you what is the length between the given 2 points. So if it is got worn out 50% also, then also you can use the chain. So that is the advantage of this chain. But what are the disadvantages? It's heavy and takes too much time to open and fold. Okay, how to open and how to fold this chain, I will tell you in the lab directly, because here if I explain it also nothing will happen. Okay, I will show you how we need to do it in the lab. Okay. It's very heavy, no doubt, because it's complete metal. The weight will be more, so we need to ensure that we are holding it properly and we're opening it up and throwing it in the field with force. So that is one typical problem with this chain, and it becomes longer or shorter due to continuous usage. Okay. So these are the disadvantages. Okay. So any chain, as you're when it is purchased, it will be good, but as long as you are using it in the field, there is every possibility that the chain get elongated or the chain get contracted. Okay, so there is a permissible limit for that to use a chain. So the first thing what we generally need to use, we need to check when a chain is being used for you, is given for you to do the surveying in the field. You need to first fix 2 points 20 meters apart using a tape and check whether the chain is exactly 20 meters or it is more than 20 or it is less than 20. Then only you need to use the chain. Okay, while you are checking that, if the error is plus or minus 5 mm for a 20-meter chain, then you can use the chain. Otherwise, if it is more than plus or minus 5 mm, then the chain is faulty chain. You need to rectify first. And for a 30-meter chain, the permissible limit is 8 mm. So if it is 30.8 mm, 30 meters, 30.008 mm is the length which you are getting when you are measuring the chain with a tape, then it's okay. But if you are getting 30.010, then the chain is faulty. You can use the chain, but you will be getting errors. So you need to do this first check whenever you are using a chain, because the chain gets degraded day by day when you are using it for continuous. Okay. So these are the advantages and disadvantages of chain and the permissible errors. Okay. The next one is tape. We have several types of tapes: cloth tape or linen tape, metallic tape, steel tape, invert tape. I'm not going to cover in deep this because you might have already seen in your day-to-day life. Have you seen tapes? Chusara tapes?
Yes.
Yes, sir. Yes, sir.
Have you used in your home? Most of the houses will have a tape, right? At least which is used for tailoring purpose also, right?
Yes, sir.
Okay, what will be there on the tape? You take any tape, okay? On one side, one units will be there, on the other side, another units will be there. What are those units?
Centimeters, inch.
So on one side, you'll be having inches, and the other side, you'll be having centimeters or meters. Okay, most of the tapes will be in the same form, whatever tape may be. Okay, so when you are using tape, you need to ensure that you are using only one type of unit system. When you open the tape, you can see here that you're having some meters here, right? Red color, 50 meters, some value is there. On the other side, it will be inches. So when you're making measurements with tapes, you need to ensure that you are making the whole measurements only in one system. Either you're using a metric system or you're using a FPS system. Okay. Some measurement you can't take in meters and some measurement you can't take in feet or inches. With that simple measure, you need to ensure that you are taking all the measurements with a single unit system. Okay. What are the disadvantages of cloth tape and what are the advantages of invert tape? Only thing is the cloth tapes may get torn out when you drag it on this rough surface. Okay, invert tape doesn't get torn out, and metallic tape or cloth tape or steel tape is subjected to temperature variations, because every product is manufactured at some appropriate temperature. If you say that the maximum temperature a tape can withstand is 30 degrees, okay, it can be used in that temperature. But if you go and use it in a desert area where the temperatures will be at 50 meters, 50 degrees centigrade, 60 degrees centigrade, this tape will get deformed because it can resist only up to 30 meters, 30 centigrade temperature. When you are using that tape in a 60-degree temperature, definitely a metal will get deformed by some small amount. Okay? That is the disadvantage of this metallic tape and steel tape. But an inverse tape will have high coefficient of thermal expansion. Okay? It can withstand high temperatures also. That is the major advantage of invert tape. So depending on the scenarios you need to use. If you use a tape in winter season, it may get contracted. If you use a tape in summer season, it may get expanded. So depending on the scenario, you need to select what type of tape is suitable for what type of works. Okay? And the next two are the arrows and pegs. You can see the purpose of these arrows is to mark the end point of a chain. If you are measuring a 100-meter line by using a 20-meter chain, you'll be getting five arrows, right? So the starting point, starting handle of the chain will be at the starting point. At the end handle, at the end handle, you'll be placing one arrow. Then you'll continue to drag the chain further. The first point of the chain will come and you need to stop at the first arrow. Again, at the second end, you'll need to place an arrow. Like that, these arrows are used to fix the intermediate station points. Even pegs are also used for the same purpose. Okay. So what is the principles of surveying? What is the principles of surveying? What you have learned in the last class? What are the principles of surveying?
Working from whole to part.
Working from whole to part.
From a fixed reference point.
Okay. So in the same way, we also have a principle for chain surveying. The principles are triangulation, that is dividing the survey area into some set of triangles. Why we need to divide it into set of triangles? Because it is the easiest figure which can, by using which we can calculate the area. What is the ultimate goal of survey? To estimate areas, right? One of the ultimate goal of survey is to estimate area. So a triangle, if you measure what is the length and what is the height, you can measure what is the, you can calculate what is the area. So the purpose of chain surveying is nothing but triangulation. That is, the area to be surveyed is divided into number of small triangles, which should be well conditioned. What is well conditioned? What is well? What is condition? Okay. A triangle is said to be well conditioned when no angle in it is neither less than 30 nor greater than 120. Okay. If the all angles in a triangle are more than 30 and less than 120, then we call it as a well conditioned triangle. If it is vice versa, then we call it as a ill conditioned triangle. That is, if the angles in a triangle are less than 30 and greater than 120, we call it as a ill conditioned triangle. And an equilateral triangle having each angle of 60 is an ideal triangle for surveying works. Okay. Whenever you are doing a survey, it is better to divide the area into a set of equilateral triangles, but most of the cases it may not be possible. That is why this concept of well conditioned triangle came into picture. Why we can't go for a ill conditioned triangle? In the bottom figure, if you are able to see these two figures, are you able to identify the vertex here clearly in this first figure? There is only single point of intersection of these two lines. Okay, these two lines are getting intersected only at one point. Similarly, these two lines are going to get intersected at one point. Okay, this is a well conditioned triangle where the angles are greater than 30, less than 120. You see in the second figure, where is the vertex? You are having some width for that, right? So the vertex is ambiguous in the ill-conditioned triangle whose angles are less than 30 and 120. So when you are plotting this in a sheet after your work is completed, identifying the position of the vertex will become a problem, which will have a subsequent effect on the area calculations. Okay, that is the reason why we need to divide the surveying area into some set of well-conditioned triangles, or preferably equilateral triangles. Okay. So what is the terminology in chain surveying? Okay. So we have survey stations. Again, survey stations are divided into main stations, subsidiary stations, and tie stations. Okay. And we also have lines, check lines, survey lines, main survey lines, base lines, check lines, and tie lines. Okay. We'll see what is the use of this. Okay. If you are able to see this figure, okay, the area ABCD is to be surveyed. Okay. The purpose of our work, the aim of the project is to determine what is the area enclosed between ABCD. Okay. So we have in this ABCD are called as main stations. They are the main stations which need to be established 100% accuracy, because your whole work is going to depend on these positions only, ABCD. So these ABCD are known as the main stations, and the line joining two main stations is called as the main survey line. The line joining two main stations is called as the main survey line. Okay, and the line joining the longest possible stations is nothing but your baseline. You can see BD is the baseline. AB, BC, CD, DA are the main survey lines. BD is the baseline. While you are establishing the baseline, you need to ensure that the surveying area is to be divided into possibly equal halves. Most of the times it may not be possible, but we need to ensure that it is passing through the center of the area to be surveyed, so that both the halves will be equal. Okay. So once we establish this main lines, baseline, and main stations, then we need to establish subsidiary stations. If you are able to see a point S2, S1, okay, subsidiary stations need to be established. Then tie stations should be established, T1 and T2. Why we need to establish subsidiary stations? We are having three buildings here and a pond. Okay. In order to identify what is the distance of this corner, what are the various possibilities we have? I want to measure what is the distance of this corner. At what distance this corner is there? What are the various possibilities in this figure? From where you can measure? Forget about S2, S1, remaining ABCD. Can you measure it from ABCD? This point? Yes or no?
Yes, sir.
Yes, sir.
So it is nearer to which point? It is nearer to D, right?
D.
It is nearer to D. Okay. But suppose I want to measure it from A. Okay. Assume that this chain is this point is at a distance of 100 meters from A. So how many chains I need to use? How many chain lines I need to use? 5, right?
Yes, sir.
Okay. If your chain is having an error of 0.2 centimeters, okay. If your chain is 20.2 centimeters, so the length of the chain which you are using is 20.2 centimeters instead of 20 centimeters. So what is the error I am going to get here?
One,
Which distance I am going to measure? I am going to measure 100.1 centimeters, right? No. 100.10 centimeters I am going to measure. The actual distance is only from A to B, this point is 100. But if I am using a faulty chain, I am measuring 100.10 centimeters. Okay, I am measuring 110 centimeters, I am measuring. Then there is an error of 10 centimeters. Okay. But if I check from D, assume that the distance is only 60 from D. What will be the error? Six centimeters, right? Instead of 60 meters, I am measuring 60.6 centimeters. So the error is 6 centimeters. Similarly, from C from D also the error will be more. So in order to reduce the errors, what we need to do is we need to go for the establishment of subsidiary stations. So the subsidiary stations, the main stations, we need to establish 100% perfectly. Okay. Subsidiary stations also we need to establish perfectly with respect to the main stations. So when I establish a subsidiary point or a subsidiary station here at S2, now to measure from S2 to this point, I may need only one chain length or less than one chain length. So the error is localized, the error is minimized here or not. From A if I'm measuring, I need to measure it 5 times, so I'm getting more error. Error is accumulating. But from S2 if I measure, the error will be localized or the error will be reduced. So that is the advantage of establishing subsidiary stations. You can reduce the measurements and you can also increase the accuracy if you establish these subsidiary stations as well as the tie stations. But you need to ensure that these stations are fixed perfectly with respect to the main stations in order to ensure the accuracy. That is the purpose of subsidiary stations. Okay. Similarly, the tie stations also. Okay. So this is regarding your chain surveying, how you are going to do it. Now you can see from this figure how many triangles it is divided. This is the whole area I want to do survey. Now how many triangles is it divided now?
4, sir.
5, sir.
You can use either this one or 1, 2, 3, 4 triangles are divided, right? Now what is the advantage of this dividing into triangles now, tell me? If you measure this distance, it is useful to both, right?
Yes, sir.
Okay. So you know anyway, you know all these 4 distances. A, B, B, C, C, D, you know. And if you're measuring only this distance now, can you calculate what is the area? Yes or not?
Yes, sir.
You know 2 sides of the triangle. Can you measure, can you calculate area?
Yes, sir.
If this is base, this will be height, or if this is height, this is base, right? Half into base into height, you can use the simple equation to calculate the area. So once you get the area of this one triangle and the second triangle, add both, you will be getting what is the total area enclosed between A, B, C, D. Okay, that is the advantage of dividing the given area into set of triangles. Okay. So main survey lines are the lines joining the main stations. Okay. And baseline is the line on which framework on the survey is built. It is the longest main survey line. This is what I explained till now. Check line. The other advantage is you can see there is one check line here. Okay. The purpose of this check line is to ensure the accuracy of your work after plotting. You will be taking the measurements in the field and you will be going back to your office and do the plotting. So in order to assure the accuracy, what you need to do is, while you are doing the surveying in the field, you need to identify a point within the survey area and measure its distance from any of the main station points. Okay. So now I'm identifying S2 as itself my point and I'm going to measure the distance of S2 from A. Or I will take S1 and I'll measure the distance from C. Okay. Once I measure this distance AS2 or CS1, I'll keep it as a record. Okay. After I convert all my recordings into a plot on a sheet with an appropriate scale, okay, during that time I will plot this S2 position also, right, on the map. So I'll measure what is the distance between A, S2 on the chart as per scale. Okay. Then I'll convert that into appropriate scale. Then the distance which I'm getting on the chart and the distance which I've measured in the field should be the same. If it is same, you can say that yes, the work done by us is 100% accuracy. Okay. So the checkline, the purpose of checkline is to ensure the quality of the work done by us. Okay. There can be any number of checklines. You can have 2, 3, 4, or 1, depending on the accuracy which you want. Okay. So what are the operations in chain surveying? What we are going to do in chain surveying? The three basic operations are there. One is chaining, and the second is ranging, and the other one is the offsetting. These are the three operations which we are going to do in the chaining of chain. Okay. What is chaining? Okay. The method of taking the measurements with the help of a chain or a tape is termed as chaining. Okay. The method of taking the measurements with the help of a chain or a tape is termed as chaining. Okay. Chaining involves following operations: fixing the stations. Okay. First, we need to fix our survey stations in the field, A, B, C, D, E, F, like that. Then unfolding the chain. So unfolding the chain and folding the chain are two important aspects in order to ensure the train is being maintained in a good condition. For unfolding the chain, what you need to do is you need to take the two handles in one hand. Okay. You'll be having two handles like this. See, these two handles should be taken in one hand, and remaining portion of the chain should be taken into another hand, and you need to throw it onto the surface of the ground. Once it is thrown onto the surface of the ground, one person will hold one handle and another person will hold another handle, and he will try to move far away from the first person so that the chain becomes straight. Okay, so the chain becomes straight and stretched completely. Once the chain is stretched completely, there is a possibility of some kinks coming up when you are unfolding the chain. So that will be removed when you are making it straight. Okay. So the person the other end should give a small jerk so that if at all there is any bending or if at all there is any kink formation, that will become removed and the chain becomes straight from first handle to the last handle. So this process is called as the unfolding of the chain. Okay. So the shape of this chain, which is now seeing on the figure, it will be extended up to 20 meters or 30 meters depending on the length of the chain. Okay. The next one is the ranging, okay, and measuring the distance and folding the chain. Let's see what is ranging. Okay. So the process of establishing intermediate points on a straight line between two endpoints is known as ranging. The process of establishing intermediate points on a straight line between two endpoints is known as ranging. Now in the figure you can see there is a station A and station B. These are my two station points, and I want to establish another 2 points C and D in between. Okay. I want to establish another 2 points C and D in between the rod 3 and rod 4 which you are seeing in the figure. Okay. So how to establish it? The establishing of those rod 3 and rod 4 is nothing but the ranging. For this, what we need to do, there are two types, direct ranging and indirect ranging. For this, what we need to do is one person will stand at A, that is the station which is already fixed, and other person will stand at station B. Okay. Two ranging rods will be kept here. At rod 1, one ranging rod; at rod 2, another ranging rod will be placed. The person who is standing at station A will move by about 1 meter back away from the ranging rod. He will bend down and he will try to see whether the bottoms of these ranging rods at A and B are in line or not using naked eye. Okay. If it is in line, okay, then he will ask the third person to hold a ranging rod at a distance where he want to establish the ranging rod at a length of one chain line, that is at the end of 20 meters. Okay. And person standing at A will give instruction. Okay, you move towards left or towards right so that the ranging rod 3 is also coming in line with A and B. So establishing of this ranging rod is nothing but the ranging operation or ranging process. Once ranging rod 3 is fixed, then again ranging rod 4 will also be fixed in the same fashion. So when you see from either A or B, you can say that all the 4 ranging rods are in the same straight line. Okay. So this process is nothing but the ranging process or direct ranging process. In the direct ranging process, both the stations will be intervisible to each other. Person standing at A will be able to see person standing at B, and person standing at station B will be able to see the point at A. So there will no obstruction. Okay? But there exist some scenarios where there is a possibility of vision problem. Okay? One such problem is here. You can see here. A person standing at A will not be able to see the person standing at B or the station B. The station A cannot see station B and station B cannot see station A because there is a elevation here. The surface is elevating gradually and again decreasing. So in these cases, how to do? Okay. In these cases, what we'll do is, so these are the 2 points A and B, which are already fixed in the ground. I want to establish M and N, and the surface is like this, where I am not able to see. So we need to move away by a distance of 5 meters or 10 meters, depending on the visibility conditions there. Okay, and select 2 points M1 and N1, so that M1 is visible from B, N1 is visible from A. Okay, you need to identify the kind of location in the field by using your common sense. Okay. 2 points M1 and N1. M1 is visible from B and N1 is visible from A. Okay. So once you stand at M1, a person who is standing at M1 and at B will give instructions to the person who is standing at N1 to come in line with BM1. To come in line with BM1. Okay. So he will give instructions, and this person from N1 will move to position N2, where B, N2 and M1 are in the same straight line. Then the person standing at A and N2, person standing at A and N2 will instruct the person M1 to move further, so that A, M2 and N2 are in line. So he's moving from this position to this position now. These three are in the line. Then again, this person and person at B will instruct N2 to move further, so that M2, N3 and B are in line. Okay. Similarly, M3 position will be identified. Like that, we'll be coming nearer to the actual point M and N in the field. So this process is called as indirect ranging, where the person standing at A is not giving instructions to person B, and person at B is not giving instructions to person A. We are giving to some other persons and asking them to move towards the chain line and establish the point M and N. So most of the cases we prefer direct ranging, but in scenarios, it's not possible to go for direct ranging, so we'll be going for indirect ranging. And all these instructions should be given only through some signals, not through mouth. Okay, if you are using your right hand and saying, giving some instruction, it is an indication that you move to the right hand, to your right hand side. The other person, opposite person, should move to your right hand side. If you are using your left hand and giving the signal, it means that the other person should move towards your left hand side. Okay, like that, there are several instructions which I'll tell you in the field itself. Okay, moving rapidly, moving slowly, etc. kind of things. Okay, but when both hands are turned to up and brought down, then that point is called as the accurate position, where you are giving an instruction to the assistant that where you're standing, where your ranging rod is kept, that is the accurate position. And when both hands are brought forward horizontally and depressed, then you are giving an instruction that you fix the rod at that position. Okay. So these two you need to clearly remember. Remaining all only handling of the left hand and right hand with speed variations. Okay. So next is offset. What is an offset? So the lateral measurement taken from an object to a chain line is known as an offset, and there are two types of offsets. One is perpendicular offset and another is oblique offset. Okay. So you can see in this figure, these are two stations A and B is the main chain line, and you're having three objects here, right? One object is D1, D2, D3, oblique offset, perpendicular offset. So the distance measured from vertically from the chain line, that is perpendicularly from main chain line to the foot of the object, is nothing but the offset, this portion. This is called as offset. This is called also offset. These two are at 90 degrees to the main chain line. That is why we call it as perpendicular offset. But if you look at this building block, you see it is at an inclination. Okay, this point is at an inclination to the main chain line. That is why we call it as oblique offset. Why these offsets are required? To ensure to find out at what distance these objects are existing from the main survey line. So once you measure this distance, you can mark a point on the drawing chart at this point, at this distance, and say that this is so and so object, this is so and so and object. Okay, so that is the offset. Okay, an offset is nothing but the lateral measurement taken from an object to the chain line. Okay, it's a lateral measurement taken from the chain line. It's nothing but the offset. The purpose of offset is to determine its position on the chart while plotting. Okay, so there are various methods of setting offsets. Perpendicular offsets in the field. One is swinging operation, second is optical or prism square instrument, and the other instrument is the using crash staff. Okay. So swinging operation is a simple technique which can be implemented when when the optical square or prism square or cross staff are not available. So what we'll be doing here is you'll be expanding the tape. Okay, you'll be unwinding the tape from the tape box, and you'll be holding the starting point of the tape at the foot of the object. This is my object. I want to determine what is the perpendicular offset. So the starting point of the tape will be held at this point, and the remaining free end of the tape will be swinged in this direction. Okay, in this direction. Where you are getting a less distance, that indicates the foot of the perpendicular offset. You can see from this figure, this distance is more when compared to this distance, right? By this figure itself is self-explanatory. This is inclined, but this is perfectly straight. So this becomes the foot of the perpendicular offset. So this technique will implement when there are no instruments available for you to establish the offset. So it's an approximation method. So we have another instrument which is called as optical square or prism square. Okay. Here what happens is we'll be using a prism. You'll be standing at an approximate position where you are expecting the offset. I want the foot of this offset, okay, where it touches the main survey line. I want this position. So I'll identify using my common sense and approximate position, and I'll try to see this object from the prism. Okay, I'll try to see this object from the prism. From the prism, I can see these two also, right? The position of A and B can also be seen. Okay, are you getting my point? So when I am at an approximate position, you can see in the bottom figure, D is at some position and A is at some position. There two are at different positions. So I'll try to move towards left or right along the chain line AB so that the images of this D and A are coming in the same line. Here you can see in the second figure. Okay. In the first figure you can see there is a difference. There is a gap between these two dotted lines, black and white. When I try to move my system, my instrument towards the left and towards the right, I'll move till I am going to get these two images in the prism at the same line. Then the bottom of that instrument gives you the accurate position of the foot of the perpendicular offset. Okay. So this is the use of an optical square or a prism square. Okay. And we have another simple instrument which we are currently having in our laboratory. This is a crash staff. We call it as a crash staff, and we have only a right angle crash staff. Okay. Where you can see that you are having a rod, and the top of the rod you are having a wooden block or a steel block which is having two slits, two openings at 90 degrees to each other. These slits which you are able to see, they are at 90 degrees to each other. So what we'll be doing is, again, we'll be in the same case as we did in this first optical square. We'll identify the approximate position where we are expecting the foot of the offset, and we'll try to see through this slit. Okay, through this slit, we'll see whether the object is visible to me or not. If the object is visible to me at that approximate position, then I'll shift myself and see from this direction. In the first go, I'm seeing from this direction the foot of the object offset. Once if it is visible through this slit, then I'll turn myself and see from this side. If I see from this side, what I will be able to see? The point A or point B I will be seeing. If these two are also visible to me, then that approximate position itself is the position of the foot of the object. If it is not seen, either of the A, B or C is not seen in that particular position, I'll shift the position here and there just minutely till I am able to see both the objects through these open slits. Okay? That position is going to give me the foot of the object. Okay? So there are several types of crash staffs. One is the open crash staff, which you are seeing here, which is available in our laboratory also. In addition to that, the purpose of this is only we can establish a perpendicular offset. We can't establish oblique offsets. But there is another crash staff, that is French crash staff, which can also be used to set an offset at 45 degrees angle. Only 45 degrees and 90 degrees offsets can be set. But an adjustable crash staff is the one using which you can establish any offset from 0 to 360 degrees. So oblique offsets can be established using adjustable crash staff. 45 degree and 90 degree offsets can be established using French crash staff, and only 90 degree offsets can be, or perpendicular offsets can be established using open crash staff. Okay. So this is regarding the instruments which we are going to see in our laboratory as part of your first unit, as part of your first experiment. Okay. We are going to determine what is the area using a chain survey. In that, we are going to use these four instruments. Okay. We are going to use crash staff, you are going to use arrows, pegs, you are going to use chain and tape, okay, and you are going to use ranging rods. Using all this, you are going to do the survey in the field, divide the given area into set of triangles or trapezoids, then take the measurements and determine what is the area, etc. kind of thing. Okay. Am I clear? You'll get to learn
Yes,
this
sir.
again in the laboratory, don't worry. The first experiment is the same thing. We'll explain you there and we'll be able to see the instrument, so you'll be able to understand more clearly. Okay. Okay. This is obstacles in chaining. This is actually not there in your syllabus, but this is very much important when you are doing any surveying technique using chain surveying. Okay. What is an obstacle? There are three possibilities where chaining is free but vision is obstructed. Chaining is free means you are able to use the chain for doing the measurements in the field, but vision is obstructed. The same case of indirect ranging, you are not able to see the other point. Okay. Okay. Second case is chaining is obstructed but vision is free. First example for first one, chaining is free, vision is obstructed, is an elevated area between 2 points. Okay, one side it is depressed, middle it is elevated, other side it is again depressed. Okay, chain, you can drag the chain along the elevated area, but you will not be able to see what is there on the adjacent opposite side. Second option is chaining is obstructed, vision is free. Best example is a pond. If you want to measure what is the length of the pond, okay, what you need to do, you need to measure from one end of the pond to the other end of the pond. Can you use a chain there? Can you drag your chain in a water body?
No, sir.
You
No,
can't
sir.
drag your chain, you can't drag your tape. In normal scenarios, if you have all measures like if you use a boat, etc., kind of thing, you can do that, but normal scenarios. So, but you are able to see both the ends clearly, right? Person who is standing on one end of the pond can see the other person who is standing on the other end. Vision is free, but chaining can't be done. It is obstructed because of the presence of water body. Third case is chaining and vision both are obstructed. So, what can be the example for this?
A large building.
A large building. You can't, if you are standing on one side of the building, you can't see what is there on the other side, and you can't even drag your chain. Okay? So these are three possible cases which we call as obstacles in chaining. But we are supposed to do the survey. So what we need to do? Will you remove the pond? మొత్తం మట్టితో నింపేద్దామా? Or will you remove the elevated area? దాన్ని బుల్డోజర్తో ముక్కలు చేసేసి లెవెల్ చేద్దామా? ఏం చేద్దాం? బిల్డింగ్ కూర్చుద్దామా? వాట్స్ యువర్ సొల్యూషన్? Here we will be using your geometrics which you have learnt in your schooling. Okay. So this is one example of chaining free and vision obstructed. Okay. There is a line AB. Okay. I want to measure what is the distance between A and B, but there is a pond. Okay. That can't be a pond. It can be a bulldozer. What can I say? Boulder. It can be a boulder. ఒక చిన్న కొండ ఉంది, చిన్నదే, చాలా చిన్న కొండ ఉంది, బట్ ఐ వాంట్ టు మెజర్ ద డిస్టెన్స్, సో ఐ కాంట్ see what is on the other side. So what can I do? I will identify a point B dash from where I am able to see both A and B. I want to measure the distance between A and B, but there is a boulder where, because of which I am not able to see A and B intervisible. So I am finding a point B dash so that from B dash I am able to see point A and point B. Okay. Once I establish a B dash point, then from B dash I can measure A B dash I can measure, as well as I can measure B B dash. Okay. You can see the angle at B dash is 90 degrees. So what is the equation I can use to measure the length AB? AB dash square plus BB dash square is equal to AB dash square, where AB is equal to square root of AB dash square plus BB dash square. This is the equation you might have studied in schooling, I hope. Yes or no?
Yes, sir.
What is AB in this now? In this triangle, what we call AB?
End points.
ట్రయాంగిల్లో అడుగుతున్నా నేను, ఏదో టర్మినాలజీ ఉంటుంది కదా దానికి. హైపోటెన్యూస్ అనే పదం విన్నారా?
Yes, sir.
Yes, sir.
వాట్ ఇస్ ద థీరమ్ నౌ?
Right time.
వాట్ ఇస్ ద థీరమ్? Pythagoras, according to Pythagoras theorem, AB square is equal to AB dash square plus BB dash square. AB is equal to square root of AB dash square plus BB dash square, right? So we need to find out how we are able to clear this obstacle and how we are going to determine or how we are going to complete our work. Our purpose is to complete the survey and determine the area. But when you have an obstacle, you need to find a way out so that we are going to complete our work with less difficulty. So this is one scenario. In the same way, here also you can do the same thing, right? There is an obstacle here. Okay. So what I'm doing, I'm making a perpendicular on either side of the obstacle. I'm drawing a perpendicular AC and drawing a perpendicular BD. So I can measure AC distance, I can measure BD distance in the field. I can measure CD distance also. Now CD is equal to AB, right, from this diagram. Do you all accept?
Yes, sir.
Sir.
This is right angles. This is, so CD is parallel to AB. So AB is equal to CD. Similarly, here also, I'm drawing a perpendicular on one side and I'm joining BC. It is again 90 degrees. So I can use the same equation. AB BC square is equal to AB square plus AC square. From that I can calculate AB square. Then simple, the same right angle triangle, again using the Pythagoras theorem, you can determine what is AB. AB is unknown here. AC you know, BC you know. You can calculate AB. Okay. Similarly here also. I am extending a line CE. I am drawing a line AC and extending it up to CE so that AC and CE are equal. Similarly, I am extending BC to CD. BC and CD are equal. If I measure distance from DE, it is equal to AB. Parallelism. Okay. So you need to draw figures like this and identify and calculate what are the corresponding values. Okay. So here also this is vision and chaining, both are obstructed. This is a building. I am not able to see what is at the other side. So I am drawing two perpendiculars on either side and I am measuring the distance between C and F, which is equal to the distance A and H. So in the examination, what happens generally is till last year, this is there in the syllabus, but this year they have removed from the syllabus, but I'm not sure whether you will get a question from it or not. But if you get a question from here, then what? They will not be giving you the figures. Okay, they will not be giving you the figures. They'll just give you the question like this. There is an obstacle in the form of a pond on the main chain line AB. 2 points C and D were taken on the opposite sides of the pond. On left of CD, a line CE was laid out 100 meters in length and a second line CF 80 meters on the right side. Okay, such that line point DDF are in the same straight line. ED and DF were measured and found to be 60 meters and 56 meters respectively. Find out the obstructed length CD. This is how you'll be getting the question. Okay, there is an obstacle in the form of a pond on the main chain line AB. 2 points C and D were taken on the opposite sides of the pond. On left of CD, a line CE was laid out 100 meters in length and a second line CF 80 meter long was laid out on the right side of CD such that ED and F are in the same straight line. ED and DF were measured and found to be 60 meters and 56 meters respectively. Find out the obstructed length CD. So how to solve this? So based on the information gained, we need to draw the diagram. Okay, this is the resultant diagram. ACB. ACDB is the obstructed line. And from C, I need to draw a line 100 meters and mark the point E. From C, I need to draw a line 80 meters, mark point F, such that E, D, F are in the same line. So from this diagram, how I need to determine CD. Okay. So you can see from the figure, let us assume that this angle is theta. Okay. This length is given, 100, 80 is given, 56 is given, 60 is given. Okay. We are having 4 lengths here. Let us assume that this is a unknown angle theta. So from triangle CEF, what is cosine rule? What is cosine rule and sine rule? Cosine rule enti? Okay, leave it. So as per cosine rule, cos theta is equal to FC square plus FE square minus CE square. 2 adjacent sides minus opposite side divided by 2 times of FC and CE. Okay. Here FC is given to me. FC is 80 meters. FE is given to me. FE is 60 plus 56, 116. Okay. CE is 100. So cos theta is equal to 80 square plus 116 square minus 100 square by 2 times of 80 multiplied by 116. So I am getting some cos theta value here from this triangle. Now again consider another triangle CDF. This angle is not going to change, right? Because these 2 lines are intact, this angle is not going to change. From triangle CDF, cos theta is again equal to, what's the value? 80 square plus 56 square minus CD square is unknown to me, divided by 2 times of 80 multiplied by 56. But this cos theta both are equal. So if you equate those two, you'll be getting the value of the unknown CD. CD is equal to 69.123 meters. Okay. So like this, you need to solve your problems. I didn't ask you any attendance, Mr. Rule number 7. Okay, you need not mention your attendance in the chat box. I'll call you.
Charging was very low at that time.
Okay. So based on the given question, first you need to draw the diagram. Then using your concepts of geometry like angles, thetas, etc. kind of things, you need to calculate the unknown value. Okay. The whole 100% accuracy of this question will be depending on the how you're drawing the diagram. If diagram is drawn wrong, then your answer will also go wrong. So you need to be very, very careful in drawing these diagrams. Okay. It's 140. Okay, I'll stop here. Number 1,
Present, sir.
3, 4, 5. I'm just noting down the values which are available here, members. You don't respond, I'll just call you. 6, 7, 8, 9, 10, 13, 14, 16, 17, 18, 19, 22, 23, 25, 26, 27, 28, 29, 31, 33, 36, 38, 42, 43, 44, 47, 48, 49, 50, 51, 53, 51, 53, 54, 55, 56, 57, 58, 59, 301, 303, 304. Okay. Right, thank you for the day. Bye.
Sir, that is our network
Thank you,
problem.
sir.